And thank you, Tori. And good morning, good afternoon, whatever your case may be. How are you doing today? My name is Barry Kuehnle. I'm with GridSME. And just give you a little bit of background. I started doing cybersecurity back in the late 90s, and I focused on supply chain and industrial control systems in those environments. I started with the Navy. In the last 15 years, I worked with the Federal Energy Regulatory Commission, specifically on the CIP reliability standards, which I just recently retired, and I am now working with GridSME here. And today I'm going to be talking about understanding and mitigating rogue communications. So before I start getting into the meat of the presentation, I just want to show this slide here so everyone kind of has an understanding of what the background is and maybe what the base is for these type of devices that may actually present a rogue communication pathway for your environment. So what you are looking at right here is a tool that you can purchase and use it for pen testing. It's about $180, and then you have to buy the software that goes along with it. But the tool itself is a USB cable. As you can see, it's a charging cable for a Apple phone. And it is designed that it has actually a chip inside, and that chip inside, provides wireless access via Wi-Fi, and it also has firmware in there that allows the user connecting through that wireless connection to gain access to the computer or whatever device it's connected into, so they can take control of that device. Obviously, you can see here, there's some keystroke capturing. You can encrypt your inbound, outbound C2 channel, the command and control, and you can set up scripts so you allow the attacker or the pen tester in this case to set up a reverse shell. So basically what they can do, they can take over that computer and then they can move laterally within the environment. So just think about this from a attacker's perspective and from a rogue communications perspective of now having a dual path that's going into an environment that you're not expecting that pathway to be going into, right? So again, please keep in mind this slide here, and specifically the size of this device right here that has the control enabled for that particular attack vector. In this case, again, it's for pen testing. Okay, so what are rogue communications? Rogue communications are unauthorized, undocumented, they're hidden, and they're usually deceptive in nature as well. So basically, they're clandestine communications that have been put into a device or software. And what was the genesis of this presentation today was back in May of this year, there was a number of news articles, and I have the link there to the one from the US News, but there was a number of news articles talking about how it was discovered that there were some cellular communication devices installed in inverter-based resources, which is also referred to as IBRs. And these inverter-based resources are a device that you would connect up to a solar panel or a wind generation, anything that has a DC current, and that inverter-based resource would convert that to an AC current, so it could be put into the grid. But what happened and what was discovered is back in May that there were some cellular modems installed in these inverters that were undocumented. So once that inverter was connected up to the system, the cellular modems initiated, and then there was a communication path that went out bypassing all of the security controls that were established at that entity or whatever entity they put it into, right? So the danger there obviously is you're bypassing any type of security controls such as firewalls, intrusion detection systems, whatever may be there. And it also, the danger is that you're not performing an inventory, you're not doing configuration management of those systems. You basically have no idea that there's communication going in and out of that device. Now, with that said, I'm not saying that these devices that are found are intended to be malicious. We don't know that, but the point is, now that they have these undocumented devices in these systems, and they have a dual pathway going into it that's completely undocumented and unmonitored. There's no visibility whatsoever within these devices. The security professional or anybody working in that environment has no idea that there's communications going in and out. So potentially the initial user of that wireless device could get in and they can gain access to the rest of the network. And if that isn't their intent, they're still exposed to the internet without cybersecurity control. So that's our big concern here, is that you have these devices, one that is connected through a dual pathway, undocumented, providing access to somebody that should not be there, that's not authorized, and it also gives access to the rest of the environment where potentially they can come in and actually be an authenticated user and move around in that environment. So there's two types here. We have intentional and unintentional. I'm going to give some examples here in a few minutes of both of those. And then I'm also going to emphasize that dual pathway that is pretty common when it comes to rogue communications, especially when you have a third-party cellular device or any type of RF device that's installed in these devices without authorization or knowledge of the end user. So let's talk about this example here. This is the first one. What you're seeing here is there's a device called the TCA. And this is specific terminology for the CIP reliability standards. The TCA stands for Transient Cyber Asset. And it's a device that you would typically take into a remote environment, or actually any environment within the Critical Infrastructure Protection Reliability Standards Network, or the CIP environments. And that device you would connect into the industrial control system or a computer or a switch, whatever you want to use it for. It's there to configure systems, to pull out logs, to understand that environment, and it's authorized to do that. So you would connect it up typically through a Ethernet cable into that environment, right? Now, what I have seen in the past is some folks, what they will do is they'll take in this laptop, and they're authorized to do that, so they connect up and they're doing their job, and then they realize that they don't have everything they need on that laptop to perform their job, right? Now, especially if you start thinking about this being a substation out in 100 miles away in the middle of nowhere, and it's very inconvenient to hop back in your truck and go back and get a file if you need to. Potentially, and most likely, if you do need that file, it's not like you're going to be able to go, okay, well, I'll just go through this pathway and get into corporate or wherever that file may be and pull that file down, right? The security controls should be limited and not allow people to just go in and out of these environments and pull things out of the control center or even corporate environments, right? So what I have seen is some folks, what they'll do is they will either connect up to a wireless network that may be existing within that environment, or typically what they do is they take out their cell phone, they convert it into a hotspot, and now they have a dual pathway connected up to their cell phone, and they have obviously connectivity going out to wherever those files may be. It may be corporate, it may be, it could be a vendor and it could be back to their environment. And pull down those files. Now, I'm sure that the user does not intend for them to be bypassing cybersecurity in the sense that it's causing a risk to that environment. But that's exactly what is happening when they do that. And the issue also ends up being that when they're doing that, they're exposing this interface here to the internet, right? So now you have the potential for someone to be monitoring or even detecting that connection to the internet now, and someone who may have malicious intent has the ability to come in through this device here and then gain access to the environment. Additionally, what could happen is this person that's using this laptop, and this is rather common as well, they'll leave that TCA in, connected up to the environment for a week or so as they do a soak test and just collect things, but they may have to collect, and they come back and get it, or they just have it connected up for extended period of time, which obviously enhances the ability for anyone with malicious intent to come into that environment. Again, I have seen this a number of times. It is not uncommon. The best mitigation for something like this is training and awareness. So folks, when they go in, they understand the dangers of having a dual pathway connectivity in those environments, and they should never have that dual pathway connectivity ever in those environments, right? Just even because of the fact that the CIP standards require you to perform a scan on devices that are being connected into it, it kind of negates all that once you have that dual pathway in that environment. So that's your first example. Your second example, this one is very common as well. I've seen it a number of times, and it's the same type of scenario. You have a substation out here, and that's the environment that we're going to talk about right now. You have a substation, and maybe it's 100 miles away from where the technician or the engineer, whoever's the one who typically goes out and configures those systems and maintains those systems. What they will do is sometimes actually buy a modem and pay for it themselves with a local service provider such as Verizon or AT&T, connect it in, pay that $20, $30 a month to avoid having to drive out, especially if it's a problematic substation, right? So now it's the exact same scenarios with that laptop. However, with the laptop, at least you have the ability, or it just by happenstance will disconnect that wireless connection, so you're maybe not always connected to the internet. In this case, you may likely always be connected to the internet because it is a modem. You're reaching out to the internet through whatever that third-party service provider may be. It's a completely undocumented pathway. It's bypassing, again, all the security controls, such as your firewall, your intrusion detection systems, and it's not being monitored from a patching perspective, from a vulnerability perspective, because no one knows that it is there. So this is, again, very common. Unfortunately, and a few years ago, there was even a case where someone has done this because they got tired of driving out to a substation. They connected in the modem. No one knew about it. What ended up happening is someone with malicious intent here gained access to that modem, gained access to the environment, and they ended up ransomwaring that environment. The security team had no idea what was going on. They were looking at logs. They were trying to figure things out. When they ended up going out there, they realized that there was a modem connected up to it, and they found the culprit that gave access to that third-party malicious attacker into that environment. Again, very risky. You should never be doing this. The best mitigation, again, for this one is security awareness, the training. The folks that are doing things like this need to understand the risk that they're putting the company at in the entire environment by doing things like that. Okay, the third scenario here we're going to talk about. Now, this is the supply chain risk, which really is what generated this presentation today. And the supply chain risk obviously was, as indicated back in the May 2025 news articles about a number of different cellular devices that were discovered in these inverter-based resources that were connected up to renewables, such as, again, a solar power or wind generator, where they'll take a DC current, convert it to AC current, and then push it out into the grid. What happened here is these were undocumented radios, and they were cellular radios. They went out into the internet, and from there, whoever had connectivity to it had the ability to come back in. They could turn things on and off if they wanted to. They could obviously monitor things, maybe in telemetry. And I want to make a statement again that we don't know if it was malicious intent. It makes sense that someone would want to have that telemetry, especially a vendor, to understand how their product works. But having it undocumented is kind of sneaky and underhanded, in my opinion, right? And that's the case that was going on here. And since they were undocumented, no one knew that it was there. The security team didn't know it was there. It's not going to be patched. It's not going to be monitored. It's very risky, and most problematic is the fact that it was a clandestine path and undocumented path going in. So getting back to it, so the attacker, or in this case, whoever that end up may be, again, not saying that they're actually attacking, but if they wanted to, they have the ability to now start moving around in this networked environment as an authenticated user, because this is a trusted device in this environment. So they're coming in, they're gaining access, they're moving around, they know what is potentially there because they're the ones who designed the product. So they know what the capabilities of that product is. And even if, as a user, if you don't have the ability to do network scans or do types of things that you would expect on a regular computer, they may have implemented that functionality and no one knows, right? We just don't know. So they have this ability to move around in the network potentially, gain access, compromise other devices. So say they compromise this computer here, they're authenticated user, and then they start moving around in that environment. And it's looking like they're supposed to be there. Because if you think about it, if you're putting the money into doing this type of activity and you're not documenting what is happening and why you're doing that, and if it has malicious intent, it's highly likely, and I know for a fact that this is what happens, is they do a lot of testing to make sure that, one, when it's installed in that environment, that the amount of detection that is against it or the ability to detect that piece of equipment is minimal. So they know what the environments typically look like going in. They know the type of security tools that are going to be there. So they test to see if they can get around those security tools, if they have, again, if they have malicious intent to getting in there. So as a security professional and someone who's monitoring these, even with the tools, the best tools that you may have, they may not detect what's happening in that environment because that attacker knew what that environment was going to look like. They know how their system is supposed to behave in that environment. They have a really good idea of what other systems are in that environment. So it makes it extremely difficult for a security professional or anyone that understands those environments to recognize that there's really strange activity going on. Okay. So why I have the Apple Watch over here is because I talked to a few folks that don't have a strong technical background. And one of the things that I've heard a number of folks say is the fact that, well, if they put a radio in there, like a cell phone or something like that, I'm going to see the antenna and I'm going to see what the device looks like. And I'm going to be able to find it really quickly. And my answer to that is absolutely not. That's why I showed you that very first picture of the OMG cable. Think back of how small that processor was and the capability that something like that has. Now that processor that I showed you in that OMG cable, it's probably the size of a small pea, a small flattened pea, or a couple grains of rice. That's how big it is. So that's going to be one, you're going to have to know that it's there and you're going to have to know what the board looks like. The antenna is going to be built into the motherboard itself or into the substrate of those the boards. So I have this Apple Watch over here to kind of give you an idea that an Apple Watch isn't very small, and Samsung's the same thing. I mean, very large, and the Samsung's the same thing. And what's inside of these devices? You have Wi-Fi, you have Bluetooth, and you have a cellular modem. Plus, you have all the functionality of a computer sitting inside of these little tiny watches. So just think of the size of that compared to what the size of the actual inverter is and the components in there. It's going to be extremely difficult to be able to detect any type of activity or any type of, especially if it's malicious, within those environments. Because if it is malicious, they're not going to label it and say, well, here's the cell phone and our pathway out, right? It's going to be hidden in there pretty well. So, like I said, I've been doing this since the late 90s, and I recognize, and I hope everyone on this call recognizes as well. And if they don't, hopefully they will after this demonstration or after this presentation today, that cybersecurity is, first of all, cybersecurity is hard to do anyway, even on the best of days in an environment that you know everything that's happening. Right. But in the case of these rogue communications, it's probably one of the hardest things to do to be able to identify. And the reason being is because, one, if there's a covert channel or a clandestine channel, because no one knows it's there, if there's that clandestine channel that's going on a separate pathway, there's no way to even really detect that unless you're doing special radio frequency scanning and things like that. I'm going to talk about that in a little bit. But there really is no method to be able to detect that traffic unless they start moving around in your environment. But then again, just like I described earlier, if they start doing that, they probably have a really good idea how you're going to respond to that and what security tools are there, and they're going to be able to work around those environments in order to do what they want to do. So with that said, there's a number of things that you can do on a day-to-day basis with your fundamental cybersecurity practices. And I just listed a few of them here. Please do not take this list as an exclusive, complete list. It is just a few pointers here. We don't have enough time in the rest of the week to really talk about cybersecurity and what you need to do in order to secure these environments. But just keep in mind that these are just a few of the main fundamental things that you really need to make sure that you're doing to give yourself a little leg up if you were to have any type of malicious activity moving around in your environment. And the first one is you really need to understand what your hardware is. You need to understand that hardware, you need to understand your software, you need to have a very solid inventory of those devices. So when you have that inventory, you understand the behavior of those devices, and it will help you later when you start doing threat hunting and looking for malicious activity. You need to make sure you keep pace with your configuration management. What that means is whenever there's an update, especially a vulnerability update, you need to be able to make sure that you can put that in as soon as possible. I recognize that in a lot of these environments, it may be 6 months to sometimes maybe even a year before you can shut things down because you need that 100% availability. It may be a long time before you are actually able to shut things down. So with that, you document that you need to replace or update those systems because of a vulnerability. And you need to make sure that those systems that you aren't able to patch with that vulnerability or because of that vulnerability, that you're mitigating those in some way, or at least documenting or paying extra attention to those devices with your monitoring tools, right? Because they are exposed and they are higher risk. You need to ensure that you're always looking at your logs and log review, and also retaining those logs. So if there is an event, that you can go back and you can see maybe when that event started, because the problem ends up being, especially in an attack like this, where it's a secondary pathway coming in, and you're moving around as a trusted user, you have no idea how long that malicious activity might have been going on. So the longer you're able to retain those log files, and recognizing that it takes a lot of effort to retain log files, but the longer you're able to look at those and have those, it gives you the better opportunity to be able to go back and look and see when that event may have started first occurring, right? Because you could look at those at the forensic evidence of those of the activity that was happening in that environment. So log review is very important. So you make sure you schedule that at all times. Understanding and monitoring your internal network flows. Oh my goodness, this one here is it's so important, and because the drawing that I did was very simple, right? There's just a few devices in there. We all know that that's not a realistic environment. There's more than 2 devices typically in these environments, but they don't always have to talk to each other or should be talking to each other. So if you understand what those communications are between each other, so for example, if that inverter should never be talking to that transient cyber asset or that computer that was sitting in that environment, but all of a sudden it is, you understand that there's something strange that's going on, and it should set up flags, and you should start an investigation to why those devices are communicating. And you could put alerts to say, okay, something just happened where these devices are communicating. Let's start paying attention to that, right? It's easy to do within that environment. Well, easy, relatively speaking. And it can be done, and it should be done in high critical environments, so you understand what your traffic flows are and who's supposed to talk to who, and how those environments look. You also need to know what your external communications are. So your inbound, outbound access, from all communications coming in inbound and outbound. If you could limit those inbound, outbound, external communications, you are a leg up as well, because the minute you have a communication that shouldn't be there, it's going to trigger something, and you should start again that investigation. So understanding your traffic flows, understanding what your inbound, outbound communications are, is paramount for understanding and protecting your network the best you can. Tracking remote connections. So this is a little different than understanding your inbound and outbound communications. So you may have a discrete list of what your inbound, outbound communications are. What you want to also understand is who is coming in on those inbound, outbound remote communications. So some of them may be a machine-to-machine communication where they are always, talking to each other, and there's traffic, specific protocols. There's a baseline. You understand what those traffics look like, and that's one aspect of that machine-to-machine communication part. But there's also vendors and users of the company themselves, other folks that will remote into these devices, to pull log files, to maybe change configurations, to just monitor things and see how they're going. You need to be able to track those communications and understand what they are in that environment. Because the minute that something changes, if you understand what those are, again, it'll give you a leg up to understand what you need to do to start that investigation. And also the access permissions. Make sure that you restrict permissions to folks to only do what they're supposed to be doing. Never give anyone full admin access unless they absolutely need it, if they're an admin or something along those lines. And even then, you need to make sure that they only have access as an admin to the devices that they should be touching, right? So you want to have the least privilege rule apply to all the permissions going in and out of those environments. And even when you're inside of those environments, like when you have that transient cyber asset, that TCA, make sure that you have the most restrictive permissions on any of those devices to enhance the security of that environment. And then lastly, this is more of a policy side of things, but you still need to review your policies. You need to make sure that they don't become stale. You want to make sure that you're doing everything you can in order to stay fresh, that your team understands that the environment changes, that there's patching that needs to be done, that there's a lot of things that happen in these environments. And I do recognize that these operational technology environments that run these control systems, they're much more static than your typical IT environment, right? Where an IT environment, they have a churn, every few years they may be getting new equipment, where these OT environments are maybe every 10 or 20 years where they're getting new equipment. However, they still may be getting updates and patches. There still may be these things that you need to do. You still should review your policies. Even if you just dust it off and say, okay, I don't need to do anything, it's still very helpful to review those policies. Okay, let's talk about some of the tools that exist out there. And this is, again, it's not an exclusive list. There's many other things you can do. I just want to touch on a few of them, and I want to break it into two separate sections here. I want to talk about the radio frequency side of things, and this goes right to the inverter-based resource aspect, where there's the cellular modems or Wi-Fi device or Bluetooth or Zigbee, whatever the RF tool may end up being that's inserted into them. And it could be all of them, by the way. There's no rule that says, well, if someone puts something sneaky in my device, it's only going to be a cellular, it's only going to be Wi-Fi. It's likely that it may be all the above, right? And then maybe even some things that are very obscure that you may not even have heard of before. So with that, finding these road communications is difficult. Again, I understand that. I acknowledge it. Hopefully everyone on this call understands how difficult that is as well. So what you should start off doing is just, doing a scan of those radio frequencies around your environment, right? So there's RF scanners that exist, and it basically just does a sweep of the different frequencies that are around your environment. You can try to understand what those radio frequencies are, and then you can start narrowing them down, what you believe is yours, and then what obviously is not. Again, this is not an easy task. It's easy for me to say to do this, but especially if you're in a rural environment or an urban environment, excuse me, where there's a lot of radio frequencies, it's going to be very difficult to do that. More in the rural environments, such as a lot of these renewables, wind farms, solar farms are today, it's possible that the radio frequencies are going to be less. But with that said, you still have cell towers nearby. There's still a lot of frequencies going around. So it's not as easy as just saying, oh, okay, well, I'm going to put it in and expect in an hour or two that you're going to be able to find something. And maybe days, maybe weeks, you're going to have to do a soak test, collecting all these frequencies up, and then hopefully you'll be able to find something. So again, it's not that easy. And you also might think, well, maybe I'll just put it in my test bed prior to deploying it. I'm going to go back to the conversation that we had earlier where I brought up the fact that if you're putting a malicious piece of device or an undocumented device in your equipment, you're going to think of a lot of different things. And one of those may be like, well, maybe someone will put this in a test bed and check and see if there's any type of radio waves that are coming out of it that shouldn't be there. So they may even build in something that it doesn't initiate for a month or 2 months or maybe even a year, right? So the clandestine nature of what some of these devices are can be very, very malicious in their intent, and they're very sneaky as well, knowing that someone would try to look for different ways to be able to detect these, right? Another type of tool that you could use is your spectrum analyzer. The spectrum analyzer, very similar to an RF scanner, but the spectrum analyzer is very visual. What it does is it looks for the frequencies. You can see signal strength, and you can narrow it down from that perspective as well. Both of these tools, I typically have not used these for a long time. I just know that they exist, and I know that some of my good friends that I've worked with in the past are very familiar with these tools and very good at understanding how they can detect radio waves, and they do a good job using these tools. I'm not one of those people, but with that said, I know people who are, and we can put you in touch with them if you need to. And folks even here at GridSME and GridSec, and specifically GridSec, have that ability to do that. Okay, so let's talk about the network analyst side of the things here, or the tools here. Now, this is the network that you own, right? So the first one with the radio frequency is potentially that dual path, that pathway that you have no control over. You don't even know that exists. The network analyst tools or analysis tools will allow you to search the network that you own, right? And there's a number of tools that are out there. Again, this is not an exclusive list. Probably the most common one that I don't know any cybersecurity professional that wouldn't understand and know what Wireshark is, because it's just so ubiquitous within the cybersecurity world. Wireshark, what it does is you'll actually connect it up to typically a switch port, where you are spanning that port. You're collecting as much traffic as you can from that switch, and you can tell what traffic you want to collect. You have it go to a device here, and you are just basically collecting all the traffic that's coming in. It's very visual, it's graphical, so it allows you to look through and filter different protocols, different IP addresses, anything that you could imagine that's going across that wire. Now, one thing to keep in mind, whenever traffic goes across the network, it doesn't lie, right? So you can manipulate what's inside of the traffic, but you're still, when you collect that traffic, it is exactly what is going across that wire, right? So Wireshark would give you that visible ability to be able to decipher that. But that goes back to what I was saying earlier. You really have to understand what your network looks like. So if you put Wireshark in and you don't have a baseline or an understanding of what your network already looks like, you're already behind the 8 ball here in that case, right? You really need to understand what's going on in your environment. PCB dump. This is a command line tool that allows you to capture traffic off the network as well. You can save it as what they call a PCAP file, and you can feed that right back into your Wireshark. So now you have that graphical representation, makes it much easier. Some people I know are very proficient at filtering and manipulating the traffic and TCP dump. Personally, I find working in Wireshark's much easier. These are both free tools, by the way. Also, there's devices that are collectors, which these collectors basically forward like your log files, those type of things that are sitting on the computer themselves, and they go to what they call a security information and event management system, right, or a SIM. And what these do is they go in, there's folks sitting in the security operations center that are monitoring these different things. They can use them if they don't flag activity, saying there's something malicious. They're there that you can look up things. And so if you're suspicious when you start doing a threat hunt. And what a threat hunt is it's an approach where you believe that your system is compromised, but you don't have any indication it is. So essentially, you start threat hunting, looking for malicious activity based on certain concepts and things that you're finding that kind of point you to that direction, right? So collectors that are forwarding event logs and that type of thing to a SIM are critical because it allows you to look into the history of the devices that may not have flagged security events. Data sources such as intrusion detection systems and endpoint detection and response tools, these actually flag when something malicious may be occurring or something anomalous. And again, that could go to your SIM. So everything is being aggregated in one location, allowing that security professional at that security operations center to be able to understand what is happening in that environment and then follow up on those. I have PowerShell written here because PowerShell is actually a very powerful tool. I use it all the time for log review. It's very, very powerful. It works on both Windows, Mac, and Linux, and it does more than just log review. You can pretty much do anything you want in a Windows environment if you're using PowerShell, but it's very powerful for log review. You can also use Bash scripting in a Linux box. There's other tools that you can use for looking at log files. There's graphical tools. There's command line tools like PowerShell. There's different things you can do, and there's a lot of other tools as well. So understand what best suits your environment for understanding and pulling in those logs and that environment. And going back to my earlier statement, it is very important to understand what your environment looks like prior to even starting to use these tools. Because if you don't understand your environment well, if you don't have a good inventory, you don't know what you're protecting and you don't know what's there. So you're already, again, behind the 8 ball on that one. And like I said, there's a number of other approaches you can use, and we'd be happy to talk about some of those in a later time. So what are some of the mitigation strategies? First of all, if you ever discover a rogue communication device, such as a cellular modem, you need to disable that, right? You need to block it, you need to disable it, you need to make sure that it potentially doesn't cause any harm to your system. I already talked about what a threat hunt is. So you should always initiate a threat hunt if you ever detect something like that, because you have to assume you're compromised, and you want to make sure that the rest of your system isn't compromised as well, right? Or how deep that compromise may end up being. So you need to do that. Let's talk about the architecture a little bit. So from an architecture perspective, what you want to do is you want to segment your network. In the diagram I have here, I have it segmented into 3 different sections. They're called virtual local area networks, or VLANs. And what you can do is you can set security controls where only the devices within each VLAN can talk to each other. It goes out to the firewall or whatever devices managing those VLANs. You can set up controls to monitor and make sure that some devices can't talk to other devices in different VLANs. You're allowed. You can set it up that they can talk, but only certain devices. There's a lot of controls you could do. So basically what you're doing is you're isolating these devices in a smaller environment to reduce your attack surface and make it easier to manage from a cybersecurity perspective as well, and also from just an operational perspective. So you can actually, again, you can put controls also in your switch to look at and control that access as well. Sensor placement, you want to make sure that the sensors that you put into these environments are monitoring the things that are critical to you. So right now I have this drawing here of the IDS sitting on the main trunk going out to the firewall. So you probably realize that that's only capturing the traffic that's coming inbound and outbound and then going to these environments here, right? So you may end up missing things. And the reason I say that is because the way networks operate is if these 2 devices are in the same network, when they go through a switch, the switch does not forward it to the firewall or to whatever that router, whatever is managing those VLANs. It'll stay within that same switch and it'll go, so it'll completely bypass the IDS. So if this is a very critical system here, what you want to do is you want to actually put a sensor in here as well to monitor their activity. And that's a standard concept. Talking to your cybersecurity professionals, they should understand what that is. They know what's critical. They know where to put their sensors. They're very sharp folks, and just talk to them and make sure you're getting the best coverage you can from a network monitoring perspective, which goes right into that continuous monitoring aspect here. You need to make sure that you're always monitoring your network, right? Because hackers don't sleep. It's a 24/7, 365 day-a-year event. There's bad guys that are always trying to get into your networks. So you need to make sure that you're always monitoring. You need to have this endpoint detection and response capability, the EDR that we talked about earlier. And those would go into like your computers. Obviously, you would have it in your TCA, anything along those lines. I don't know of any EDR solutions right now that can fit in this industrial control systems. That does not mean there aren't any, but knowing that industrial control systems play a different role, and EDR is it requires some processing as well. So just you might want to check with some of your vendors to see what opportunities you have for putting EDR in as many devices as you can. Obviously, you want to enable all the logs. I put an example of Sysmon here. Again, Sysmon is a free capability. You put it into a Windows machine, and it enhances your logging capabilities. Some type of analysis that you can do. Open source intelligence, that's what OSINT stands for. You definitely want to make sure that you're always paying attention to what's happening in your environment, right? So for example, if I wanted to go out and buy a new inverter, an IBR, and I say, well, Huawei is a really cheap IBR. I think I'm going to go with Huawei, and then I start doing some open source intelligence and start doing some research and finding out that that they're banned, that there's potential for backdoor activity in it. There's a lot of concerns wrapped around those devices. I would typically stay away from doing that just based on the open source intelligence I'm doing. Now, that was a very high level open source intelligence. You can get very deep, and it's very important to understand how robust and how important open source intelligence is, because it directly feeds into your supply chain risk assessment process, because you want to make sure that you do that supply chain risk assessment as well whenever you're purchasing a product. And even once the product's in place, you want to make sure that you're maintaining that risk assessment of those devices, because you have patches coming in, you have updates, vulnerabilities, all these different things, because the typical approach of an attacker is to get a device into your environment that is completely fine, and then as the updates come, that's where your vulnerabilities and your backdoors come in through there. Again, threat hunting, perform regular audits, do pen testing, penetration testing. It's an important aspect, so it shows where your vulnerabilities are. But not only does it show where your vulnerabilities are, it gives you an idea of how an attacker would move around in your network. So it gives that cybersecurity professional an idea of what is critical and what they need to protect, and how those devices are being compromised. And I can't overemphasize how important training is. I use those first two examples, and I said, well, if those folks had really good training and understood the severity of just plugging in a modem, or having a dual pathway for their TCA, they probably wouldn't do it, right? Hopefully they wouldn't do it. But it just comes down to training for doing that. So you just reduced your risk tremendously by making sure that people thoroughly understand the importance of maintaining and practicing good cybersecurity, because it's everyone's job is cybersecurity. Okay, we're coming here to the end, and I just want to talk a little bit about the CIP reliability standards, because like I said, I've been doing this the last 15 years, focusing on the CIP standards. And this is, GridSME does work in the electric sector, so it wouldn't be prudent for me not to have a discussion on CIP. So I'm not going to go through all the CIP standards, and I'm just going to touch on a few highlights of each one of them. This is obviously not the detail behind the CIP standards, but I just want you to understand that the CIP standards actually really help you with a very good baseline for detecting some of these rogue communications that are in your environment, right? It's going to be very difficult for any standard or anyone to be able to detect that dual pathway going out, like a clandestine radio that was installed in those inverters, right? So let's talk about CIP3 and CIP5. Both of these controls, they require you to monitor inbound and outbound communications. CIP3 is for your low impact. CIP5 is for your medium and high. And for you folks who may not have a good understanding of what the CIP standards are, low impact are those devices in the bulk power system, or those systems in the bulk power system that if they're rendered inoperable, they don't have a major impact to the grid, right? So they're less of a risk to the grid individually, where in CIP5, it's medium and high impact, and if those devices are impacted, it may have a detrimental effect to the grid. So that's the difference. There's more cybersecurity controls for medium and high, as you can imagine, because of the impact of the grid, where the low impact obviously has those less controls just because of the fact that the impact of the grid reliability isn't as severe. Again, understanding those inbound, outbound communications is key, no matter what level of impact rating you are. CIP 7, these are your endpoint type controls, where you're looking at ports and services on endpoints. You're looking at configuration management, malware detection, log retention, access controls, those type of things. That's really critical. Now, again, since this is a medium impact, and all the rest of them here are all medium and high impact, right? CIP 3 is the only one that's low in this list. But just because CIP 3 only covers low, you should really apply the controls for these other ones in your CIP 3 environment as much as you can, and do those best security practices, because it's going to help you at the end. CIP 8 is if the bad day does occur, and that's your incident response and recovery. So you just end up detecting that there's something bad happens in your environment and you need to respond to that. CIP 10 is your configuration management. So that's where you're making sure that any type of vulnerabilities are being addressed. You understand what your environment looks like, and it's actually requiring you to refresh what that environment looks like every so many days, right? So you can't come stale with that standard. CIP 13, that's your supply chain risk management, and what that does is it makes you look at what those products are even before you put them into your environment, which is a very good thing to do. I think that hopefully the presentation that we gave today kind of gave you an idea how important understanding your supply chain is before you even start installing things. And then this last one, the Federal Energy Regulatory Commission just in the last week approved CIP 15, and CIP 15 is your internal network security monitoring. Prior to this being approved, there was no requirement to monitor within a network, only inbound, outbound controls. So now for inside of those networks, there's a requirement that you're going to have to monitor and look for malicious activity and lateral movement within that environment. Okay, last slide. Closing thoughts. My closing thoughts here are, one, hopefully the takeaway for all you folks are that rogue communications are going to be very difficult to detect. I went through this really quickly, and I gave you some ideas, and I'm sure that a lot of folks on this call already had those ideas and said, okay, Barry, you probably missed quite a few things of what to do. I understand that. I just wanted to touch on things here to get people, give it a thought exercise so people can start moving down and thinking, oh my goodness, maybe I should really start paying attention to what my supply chain looks like and what my environment looks like, because it could become a bad day quickly if I don't know that. But I understand it's very difficult to detect those communications. Robust cybersecurity controls will help. Something is better than nothing. In defense in depth, which is layered defenses. So that's the best approach that you can have. Basically what you're doing is you're saying, all right, I'm having a layered defense that if one defense fails, then I have another defense that might be able to pick up where that one missed it, right? So important to have that defense in depth strategy. The CIP's reliability standards are set up with that defense in depth strategy in mind. It's a must. And I can't emphasize enough, so you really have to understand your supply chain, perform OSINT, have a team that goes out and they do that research continually, not only with your vendors, but with your partners, with everything that you can imagine related to your environment. You want to understand what type of access people have into your environment. So segmenting, I have these drawings down here. Segmenting is very important. It's going to help things out. And yeah, so that's it for today. I'm happy to take any questions in the few minutes we have. I just want to stay here that, GridSME and GridSec, we're both here to help. Please reach out to us if you have any questions. Again, GridSec, they have the capability to look for RF type devices. They're very, very good at implementing cybersecurity controls and environment, performing your standard managed security service providing capabilities. So with that, I'm going to stop talking and see if there's any questions.
Yeah, we've gotten quite a few questions in the chat, so thank you everyone. I'm gonna go ahead and read off the first one. Were the specific OEMs for solar inverters publicly identified regarding the rogue devices yet?
It depends what you mean by publicly identified. So if you do a search, you'll find some news articles that will actually name some of the vendors that had these rogue devices inside of them. But I have not seen anything that was publicly announced by the US government or other governments. I know that the European Union is looking at this event as well. But I have not seen anything officially from a government agency saying these are the companies that have these devices in them. But if you do a search, you'll find what some of these names are.
Okay. Also, are you guys able to unmute? Can anyone test for me? I tried to change the setting, but I'm not sure if it worked. Thinking that might be a no. I'm going to keep reading them because I think that WebEx might be having an issue. So, okay, we have another one. If a bad actor is able to know what the environment should look like or behave, how can you tell when it's normal expected comms versus a bad actor or rogue comms? We've been discussing IVR, but is there a difference between newer system and some of the older conventional generation?
Yeah, that's a really good question, and that's why cybersecurity is so hard. If you understand the best you can what your environment looks like, and the attacker understands what your environment looks like as well, the attacker doesn't know the nuances of your environment, right? So they may know what a particular relay, how it behaves in the network, and even the protocols that maybe particular relays have, and uh, in different protocols that are around working around in that OT environment. But you, as the operator, know exactly what's happening in your environment, right? And if you document that and you understand that from a baseline perspective, and your security operations team understands that, you can create alerts based on how that activity occurs within that environment. And I used the example earlier, if one machine, such as like the inverter, should never be talking to the computer, and all of a sudden it is talking, then you will know that something obviously weird is happening, right? Or if all of a sudden one of your devices tries to reach out to, the control center when it never has done that before. So baselining and understanding your environment, it's hard to do. I know I'm saying that, that's what you should do, and I recognize it's hard to do. There's a lot of traffic that's moved around, but really, because of the fact that they have these clandestine nature communications coming in, and it's so hard to detect, you need to do everything you can in order to give yourself an opportunity to be able to detect that movement.
Awesome. Okay, I think you guys should be able to unmute now. But there was another question. Another one we have for the Q&A, how does supply chain risk management help us catch or prevent rogue communications, especially when we're using third-party hardware or software?
Yeah, that's a tough one as well. Now I know exactly where you're coming from. So you do a supply chain risk assessment for the vendor, and the vendor intentionally put a backdoor in their device, and you say, do you have any backdoors in your device? And they're going to say, no, I don't, because they intentionally put it in, right? So that's where the open source intelligent aspect comes in, that's paired with your supply chain risk assessment. So you perform that, and you look and you try to find as much information as you can on that particular vendor. What their security posture is, any type of activity that may have drawn suspicion in the past. And unfortunately, if that information isn't available, things are going to slip by. So that's why whenever you perform that initial supply chain risk assessment, you don't just put a fork in it and say, okay, I'm done, I don't have to pay attention to it anymore. You make sure that you're continually monitor the supply chain risk assessment perspective. And again, I recognize it's hard, it's a lot of work, but you just need to do that. And that's why you have that defense in depth strategy. That's a good question. It's a hard question to answer, because it's almost impossible to go after someone who's, again, already has malicious intent and ask them if they have malicious intent, because they're just going to lie. So.
Okay. Awesome. Next question. We've got quite a few. From Paolo, does ZIP 15 apply to all impact categories or only medium and high? And a follow-up, does GridSME have any indication on what NERC may do with the recent warnings on rogue comms devices found in IBRs? Or do you have any indication if they will be sending out a NERC alert or RFI, etc.?
Okay. So two-part question. So the first one I'm going to address with CIP 15. So that's a very good question. So CIP 15 addresses all high. So whether it's routable or non-routable protocol within that environment. So all high must be covered by CIP 15. The only standard that exists right now is CIP 15-1, which is for those cyber assets within the electronic security perimeter. So all those assets have to have CIP 15 apply to. However, the new order 907 require that NERC develop an additional modified standard to include ECMs and PACs in those environments, right? So that's all high. For medium, it's only medium with ERC. So the exact same scenario applies right now. The ERC side for medium only applies within the electronic security perimeter, but they have to have a modified standard that includes ECMs and PACs in the future. And for what NERC is doing with the inverter-based resource, I have no insight into that. My recommendation is to reach out to wherever you may have a contact at NERC or within the regions and see if they have any insight into that.
Awesome. Next question is, who is reverse engineering the undocumented embeds and who tests the equipment?
Would you mind repeating that, please, Tori?
Yeah. Who is reverse engineering the undocumented embeds? I think that might be like embedding, embeds. Who tests the equipment?
Could you drop it in the chat? You seem to be breaking up. I'm sorry.
Yeah. No. Okay. It says here, I'll comment it back down into the chat. Can you see that one now? I just pasted it down. So there's quite a few, but it says, who is reverse engineering the undocumented embeds and who tests the equipment?
Okay. All right. Okay. Now I understand the question. Okay. Good question. So a lot of private researchers are the ones who are reverse engineering the undocumented embeds, right? As you can imagine, it's very time consuming. The researchers typically have to have a reason to do that, because you just imagine how many devices that are out there that, I mean, you can't do everything, and you can't reverse engineer everything. It's a very time consuming process. And who tests the equipment? So typically what ends up happening is once these researchers end up looking at and doing the reverse engineering, then they'll either perform obviously the test themselves, or they'll have a third-party verification of what they're finding is accurate. That's from a security researcher perspective. I also know of a number of entities that also reverse engineer their devices, and obviously the term undocumented, if it's undocumented, you have no idea it's there. So you're almost doing a threat hunt on your hardware and your software when you're going into those systems and looking to see, based on suspicion, what is happening in those environments, right? So some entities do that. They have very robust programs to do it, and they also test those in their own environments as well.
Okay, awesome. Next question is, what are some early warning signs or red flags teams should look for during regular log reviews or threat hunts that could indicate rogue communications are present?
Good question. So you definitely want to look at connections, right? That's probably one of the first things you want to do is just start looking at see where some of these connections are going, both internally and externally. So again, going back to the scenario where machine A should never be talking to machine B, and all of a sudden it is, and that connection is established. That's an indicator. Same thing for inbound, outbound. You want to look at connections. Once once you exhaust that and everything seems normal, if you're still suspicious and you're performing that threat hunt, you need to start looking at how those protocols are behaving. Maybe you look at traffic that's encrypted, which should never be encrypted. And you have to, you as a user should identify and understand what systems and devices within that environment may be most critical to you, or maybe even be most vulnerable to you from a vulnerability perspective. And so you might want to start looking at those as well to see if those were the first machines that were compromised. Look at those log files and any anomalous activity within those also. Threat hunting and looking at log review is a very painstaking process, and that's why I honestly having that log retention is an important aspect as well.
Okay, and then I think this is our last question. We often hear that unless you are threat hunting, you are already behind. Yet we're also told that threat hunting or pen testing in an OT environment is challenging at best. Can you discuss some of the nuances or differences of how you would threat hunt in an IT versus OT environment?
Yes. So IT environment, as you can imagine, there's a lot more traffic going around in there. It's a very fluid, dynamic environment. Not that an OT environment is not dynamic, but it doesn't have the dynamics to the level that an IT environment does. So focusing in on the OT environment, again, I would start a threat hunt with the systems that are acting weird, maybe that are, again, more critical to me. I would potentially think, okay, well, my EMS is pretty important to me, and one of the computers keeps shutting down or having issues there. So you as a security professional would understand what is important to you, what that environment looks like, what that baseline looks like, and start threat hunting based on those environments and those devices. But you also, if you have suspicion that it's a certain company, or not company, a certain country or a certain attacker type that is coming after you, there's a number of tools out there, and MITRE ATT&CK is one of those tools that you can use, where you can go and you can understand what those different threat actors on how they approach things. So for example, if it's an attacker that focuses on Active Directory, right? So you would look at your Active Directory environment, and those are Active Directory environments exist in both your OT and your IT environments, typically, because you need to manage access controls. What you would do is you would look at the characteristics of that attacker based on that MITRE ATT&CK, and then that's how you would start your threat hunt, and you start spidering off from there.
Awesome. Well, I think that concludes all of the questions we have. Unless anyone else has any others, we can hang on for a little bit. But thank you all so much for joining. Very great job. That was super insightful.
Thank you.
Oh,
and it's good to see some of my old friends on the call here. Hello, Brian. Hello, Rick.
Awesome. This recording will be available on YouTube. I'll try and get it posted either today or tomorrow. But yeah, thank you all so much, and I hope you all have a great rest of your week.
Yeah, thank you.
Thank you very much,
everyone, for coming.
Good stuff.
Take care.